So this formula is so important. This box right here is so important. It bears repeating. So this is the sampling distribution of sample proportions. Every survey, Gallup poll, CNN, Pew Research Foundation, I mean, pick something. Anytime somebody is polling or surveying, it essentially can fall into this category, which means it's going to be a really big deal for us for chapters 9, 10, 11, and so on. All right, so let me just reiterate. This statement up here at the top, n, little n, which is the size of your sample, like in our example was the size of the scoop, is less than 5% of capital N. Capital N is the population size, like the number of beads in the box altogether, right? So capital N is how many beads there are in the box, how many people there are in the sample, or in the population, excuse me. And then little n is how many beads are in your scoop, how many people you actually call up on the phone and talk to, right? And then you need n times p times 1 minus p to be greater than 10. That was a formula at the very end of 6.2. If you go back and look at the notes, that's what ensures normality. And we want normal. I mean, if we don't have normal, then we can't use norm dist and norm inverse, and we've got all sorts of troubles. Then we know the mean is p and the standard deviation is this lovely formula here, and both of those come right out of the binomial distribution. Okay, so let's look at this. According to a recent article, 98% of the people who travel on the New Jersey Turnpike exceed the 60 mile per hour speed limit. Law enforcement officials are planning to covertly measure the speed of cars, 750 cars on the turnpike, and will compute the proportion of drivers who exceed the posted speed limit. Okay, so let's start with, they want us to describe the sampling distribution. So shape is normal. Now I have to prove that it's normal, so let me prove it. Oh my goodness. There we go. I could type. Okay, so I need n times p times 1 minus p to be greater than 10. All right, that's 750 times 0.98 times 0.02, which according to Excel, oops, that's the old problem, 0.98 times 0.02 times 750 is 14.7. Huzzah! Bigger than 10. That's all I really wanted. Equals 14.7, which is greater than 10. There we go. Oh, and let's just talk for a second before we go any further about independence. Oopsie, if I could spell it. Sure it is. Because 750 is well below 5% of the population. Well, you say, how do you know that? They didn't give you the population. That's true, but we're talking about the New Jersey Turnpike here. Okay? New Jersey Turnpike flows right by New York City. It's one of the most populated areas on the planet, right? So just realize there's a lot of cars. There are a lot of cars on the New Jersey Turnpike. Okay? It's waving our hands a little bit like a magician. You know, abracadabra, ta-da! It's independent, but it has to be. It just couldn't be any other way. All right, the center is the mean, oh my goodness, mean, there we go, of the p hats, which is like this. And that's equal to p, which is equal to 0.98, according to our lovely formula from the previous page. And then the spread. That's sigma p hat, which is equal to big square root p times 1 minus p over n, which would be equal to big square root 0.98 times 0.02 over 750. And I'm going to make Excel find that for us. Oops, I forgot to press record. There you go. Square root 0.98 times 0.02 over 750, and it's 0.00511. Oopsie. There it is. There we go. We've got our shape, we've got our center, we've got our spread. We'll find probabilities with our next problem.